Thank you very much. Good afternoon, everyone. So over the next 15 or so minutes, I'm going to walk you through a story, which is actually a real case study that I have gone through to really demonstrate what happens when we are relying heavily on AI, and AI is doing what it's supposed to do, but the decisions that are coming out of it aren't the right decisions. So what would happen with that disconnect that we often see between the business and the technical team? And there's a lot of finger pointing and blame. And hopefully by the end of this session, you'll have some takeaways which could help you in real life to avoid some of those situations. I'll try to keep 5 minutes at the end for any Q&A. But if we run out of time, you can come see me we have one of the stands at 251, and I'm happy to have a discussion with you after that as well. So let's get going. So one of the things that we are seeing in the marketplace, this paradox that we're going through, on one hand, everyone wants to deploy AI to do, various activities in sales and marketing, in supply chain management, optimization, but also within risk and compliance side. So for today's talk, I focused on the use case of, the risk and compliance side, which is more around how do you detect fraud and how is AI used in that aspect. So going back to the paradox now, there's a lot of investment in AI. So if I look at the stats here on the screen, you see that we have 10.5 billion, which is prevented, fraud using AI systems. So a lot of the insurance brokers, the banking, all of those organizations use fraud detection systems and algorithms using machine learning and AI, and they have been in place for a while. And they're doing a good job. They're preventing fraud. But at the same time, we noticed that, this is, again, I'm not making these numbers up, but these are the numbers that are backed by research. So there's research that has been done, and what it's showing is that 61% of the customers, they reduce their usage after a false positive. So what that means is, you are using your credit card. We all use our credit cards for this event. Let's say that the system incorrectly identifies you as a fraudulent activity, so it's going to block you. And what happened as a result of that is that a lot of consumers lost trust in that credit card holder or credit card provider, and they stopped using their cards for different types of transactions. So that's 61% of that. Now, 8-to-1 number is the ratio of false positives to real fraud detected. So when AI systems are being used and they're detecting fraud, for every transaction that they're detecting correctly, there's 8 incorrect detections that happen as a result of that. So that's what the false positives are. And then due to that, organizations that are dealing with this are losing about 443 billion annually due to declined false positive transactions. So just let that number sink in. That is a huge number. I know there's a 10.5 billion green number, but if you compare that to the red number, that is a significantly higher number. And what that is causing is it's causing loss in trust due to these declines, right? So companies and organizations, they're spending a lot of money, but the user experience is not what they had hoped for or what they had desired, and as a result, the trust is declining within the organization, but also outside if there's any consumers that are being targeted or that are being impacted by this AI. So again, going back to what I said earlier, the AI might not be at fault here, right? We have all the right models. We have data science organizations and teams that are spending a lot of time creating those algorithms and models. There's data scientists that are gathering data that's available to them to feed into these systems, training these systems. The math checks out, the patterns are being detected. Eventually, in the lab or in the QA system, everything is working as expected. So there's really nothing happening with the models. The efficacy of the model is there, what it's supposed to be. But it is failing to meet the end user needs. So again, going back to the paradox slide that we had, we have high false positives. The models are working, but we're getting high false positives. We have frustrated customers that don't want to do business with us. They don't want to use their cards. And we have low trust from data analysts or the business analysts that are utilizing or stewarding the output of this AI system. So how do we prevent that? And we'll get to that in a minute. But I wanted to make this real. So this is a real use case that I have put together. I have anonymized the customer because to prevent their brand and privacy, but this is a real example. This was a global organization that we worked with. They were a financial institute dealing with credit cards, banking, and all the stuff that we talked about. They had spent a lot of money, millions and millions of dollars, on advanced ML fraud detection systems to put in place. And I think over the last couple of years, you'll recognize that with the evolution of ChatGPT and stuff, AI has become to the forefront. In fact, if you look at this conference alone, every single talk I think we had here had some sort of AI in it, right? And all the stands that we have, there's a lot of AI happening there. And there's a lot of pressure on organizations to do something with AI, and that's exactly what was happening with this organization. There was pressure from the board, the resources were scarce, and they wanted to be efficient with what they were trying to do. So they invested a lot of money in creating these systems and teams that dealt with fraud detection systems and creating that. But with all that investment, their false positive rate was still about 12%. In the industry, the average is about 6% is what they expect it to be, but there was 50% more than what their peers were seeing. They were losing about $420K per month in unnecessary manual reviews. So there were a lot of business analysts, financial analysts that had to look at transactions that were being flagged as, there's some activity happening, but it may not be true. So they were spending a lot of money on manually stewarding that information. And the customer complaints were going up. Now, again, I don't know about you, but if I am a customer whose credit card keeps getting declined for no reason, I can't carry on with my life, especially if I'm traveling around the world, that is a lot of nuance that is creating for me an inconvenience. So I will be dissatisfied, so my complaints obviously will go up. So their complaints, 35% year over year. Ever since they implemented the system, their complaints kept going up. And the analysts who were at the end of it, their trust in the system was declining. So it had about 6.2 out of 10 is based off of the survey that they did, was the trust index for the analyst. So there's a lot of red flags you can see from here. And the management was struggling, and they were trying to figure out why is this happening, what is going on. So they would spot check. The analyst that I was referring to, they would pick a few records and they'll say, okay, so what is happening? So this is just one example. So there was a customer, let's call it Sarah Chen. She had been a loyal customer for 8 years. She was in the CRM system, she was in the MAP, marketing automation, loyalty support, transactional database, and various others. There were transactions that were coming in real time as well from her because she was using her card, her banking, and all that stuff. And what the system was looking at when they were looking at this record coming in, instead of looking at Sarah as one customer, the model was treating it as multiple customers and multiple entities. And as a result of that, because of the variations in the names and the variations in the payload that it was getting, it was detecting it as a fraudulent activity. Now, again, if I go back to what I said earlier, the model was doing what it was supposed to do. It felt like there's some pattern that should not be there when it's a legitimate, transaction. Why is this particular name variation coming in so many times? So it was flagging and detecting. But in fact, it was one customer, and it was, making a legitimate transactions. So here's another example. So think of this scenario. You have Robert Smith and Bob Smith. Now, if you just feed this data, and there could be hundreds of variations of that name in the system depending on the complexity of the organization. If you look at this and you feed this data to an AI system, it's obviously going to make decisions based off of the variations and treat them as separate customers or entities. But when you go through some sort of resolution activity, you come down to that it's really just two people, Robert Smith and Bob Smith Sr. Now, if the system takes one of the variations of Bob Smith and puts it with Robert Smith, you're going to run into a problem because it's going to, say, well, this is the same customer and there's some issue with this customer, so I'm going to flag it. So this is another example that we came across when we were trying to solve this problem or help the customer figure out what was going on. So let's go to the next one. So as a result of that, what they did was the root cause analysis, right? The first thing you look at is something must be wrong with the models. There's always, technology's fault. They did something wrong, so the models are not working. So they went through the models, Can we tweak the models? The data science team said, okay, so we can try figuring out if there's any, hyperparameter tuning, if there's any more data that can be brought in as a training component of it. We could try to discover and figure out more features that can be added to make better decisions. So all of that stuff was done, and the problem was still not fixed. They were still detecting, false positives. And what they realized is that this was not a model performance issue. What it was really just understanding who was who within the training system that the models were using. So, as an example, when further analysis was done after the models were reviewed and updated, the analysis shifted over to the data that was being fed to the models. And what they found out was that one person had, on average, about over 3 identities in the system. So there were 3 different variations of that customer in their systems that were being entered, and the model was treating them as separate entities versus just looking at it as one holistic entity. Their data was fragmented, so one system had some attributes, the other system would have different attributes, so there was no cohesive, comprehensive view of a customer or entity that they could use within their decision-making systems. And then incomplete training data as a result of that. So now we understood what was happening. What can we do? Now we could fix it, right? So what they did was then, instead of taking all that data from all those sources and treating that data as cohesive, comprehensive data for the training model, they implemented match entity resolution. So they brought all those systems together, and the systems basically then, the sources of data came in, and the entity resolution capability that was put on top of it before the data went into the training models, it made sure that the duplicates were removed. It made sure if there's any incomplete data that is needed for a feature, and parameters, it was added as required. And then it also made sure that it had identified single entities versus multiple entities being brought together or looked at separately. So that was done initially, and then ongoing basis, they implemented this real-time entity resolution capability. So they created this microservice that for any data that is being added on ongoing basis, the system would be able to bring that in and resolve those records in real time before they went into the system to decide whether this was a fraudulent activity or not. So what happened after that? So they did this, they tested it for about 6 months, and what they realized was that within 6 months, the false positive rate went from 12 to 3.2%. So they were better than industry average. Their monthly manual review costs went from 300K from 420 to 112. 5% increase in fraud detection accuracy. And then 44% increase in analyst trust in AI. So the analysts that were reviewing this now felt comfortable that the system is doing what it's supposed to do, and they started trusting it more, they started using the system more. So what that really means, and as a key takeaway for you all, hopefully this would be beneficial for you in your projects for AI, is one is identity is foundational, and I'm sure you have heard this before, that data is still paramount and foundational for AI to work. But what I would add that on top of that is data alone can't really solve the problem. You need to make sure that you have high quality data. And one of the foundations of that could be to help you bring data together, and that is the matching capability, deduplication capability, adding quality information to it from, if you don't have it, third-party sources can augment that, right? So once you have that capability, your AI systems will feed off of that, and it will make decisions that you're expecting them to make. Better models not necessarily mean better results, as we saw from this case study. And then finally, the trust requires context. So complete entity view basically help you enable accuracy and explainability. So if you have a comprehensive view of a customer, supplier, or vendor, you could provide that context to anyone who needs to use it for end use cases. Even if you're using data stewards or analysts, they'll have a little more context now to say that, okay, so this activity is being detected. Why is it being detected? If I have some metadata and audit trail that tells me this is why I did it like this, then I can be a bit more confident in using that system and making decisions. And then finally, as I mentioned, we do have a stand, and Senzing is one of the ER providers with a lot of capabilities. But if you have any questions, you need to understand more, you can come up to our 251 stand right across from the stage out there, and we'll be happy to talk more about how we have done this for other customers, And with that, I will, as I said, I'll leave 5 minutes for questions. So we are at 1:55, so any questions, happy to answer. Thank you.
I think we've got a question over here.
So I think this is very specific to the thing that you laid out in front of it. But I'm curious in terms of like, it's solving a problem where you are using a card and you're just tapping the card. So has any way, in any way, basically using kind of like a credit card via that requires a fingerprint analysis through your phone or something like that, has that helped solve certain problems like this in terms of like thinking of a way outside the box of the model's not wrong,
right?
It might not even, the data might be slightly wrong, but also there's many ways to solve a problem.
That is a great point. Yes, definitely. So in this case, this was very specific to the example that I shared, but what I am seeing evolve is a lot of these biometrics that are playing into the picture now and adding a bit more privacy and security to it, right? So it will definitely help, but I haven't come across it personally yet with customers because they're still trying to adopt that.
Thank you very much. That was fascinating. Based on that first slide, so 10 billion lost in, 10 billion prevented in fraud, but 443 billion lost in revenue. Just based on the, forgive me if I misunderstood something, the improvements that you quoted, this would still lead to losing more in revenue than preventing through fraud. So it's an improvement, but it isn't a solution necessarily.
Definitely. So that's exactly what I was trying to make. The point here is that even though the AI systems are helping prevent revenue loss, but if you look at it aggregate, it is still losing a lot more money. So the systems weren't working as expected, and therefore we need to something to make them more efficient so the scale flips over to the other side. Definitely.
Thank you very much. Very interesting. I was just wondering when you were doing listening to that, whether there's a separate issue as well that might could benefit from improvement. So you were saying that you have this, multiple entities and such like, and that problem wasn't picked up during training. So I guess in my head, either the proper training data should actually be representative of real world stuff, or if it was representative of real world stuff, would a better sort of like training algorithm, with a better, more appropriate cost function, loss function, would that also improve for the situation? And even though what you did, clearly you made a massive improvement, that's great and that's all and good, those 2 points, are they still not, one or other of those, depending which way the problem was, are they still not worth doing anyway?
Definitely. No, they're definitely worth doing. And, you always want real-world representative data, but in this case, what was happening was, in this customer's case, it wasn't real-world representative, it was fragmentation of data, right, within their systems. So the transaction that's coming in, it might be real-world, and the system is detecting it, but it's unable to process and match it to what it had in the data set, right? So I agree with you. If you can do a better job with the training data, I would say the second point you made, definitely you will see improvements here, yeah.
Thank you very much for the presentation. My name is Eva. I just have a question for you. I was wondering, in your experience, what are the early warning signs that maybe this AI system could be not necessarily giving us a holistic view about it?
That is an excellent question, Eva. So it depends on the use case. So if I go back to fraud, the early warning signs are you getting a lot of data, a lot of transactions that are being fed over to your analyst team to manually review, right? So you want to be careful of that. The whole point of this AI system is to help you eliminate that. But if it's going up compared to before, that's a red warning sign. Secondly, in data management or even MDMs or sales and marketing, if you are wasting a lot of money on, let's say, we'll use sales and marketing, you're spending a lot of money on marketing campaigns, you're not seeing the return or the traffic back, that could be another area to investigate and see, is my AI that I'm using to target these customers not doing what it's supposed to do? So I would say it depends on the use case, but you will see some early warning signs, and the biggest one would be your expectation and then comparing it to the benchmarks you had before. Thank you so much.
Thank you. Let's have another round of applause for Dr. Gurpinder Dhillon.